Hi everyone, I'm going to go over the parts information from the SumoBots programming workshop. Let's start with a breadboard. A breadboard is a base for building all electronic circuits. This is where we'll connect different components and make them interact with each other. Breadboards have rows that are internally connected, allowing an easy setup of circuits. There is also a central partition that separates each side, which makes it easier to organize our connections. Next, jumpers. Jumper wires are essential for connecting different components on the breadboard and building the circuit. They let us connect parts like the Arduino sensors, the Arduino Nano, and various other components. Jumper wires come in different types: male to male, male to female, and female to female, depending on the connections we need. This flexibility makes it easier for us to rearrange components and modify our setup as we test different designs for the SumoBot. The Arduino Nano. The Arduino Nano is a compact microcontroller board designed for building electronic projects and prototypes. This is essentially the brain of our robot. We can power an Arduino Nano by either the USB port or an external source. Let's talk about the pinout for it. The Arduino Nano has a total of 30 pins, but we're going to focus on a few key ones. There are 14 digital input-output pins, which can give readings of high or low. These pins can receive signals from input devices such as buttons and sensors, or send signals to devices like LEDs. The V-in pin lets us power the Arduino Nano with an external voltage between 7 and 12 volts. The inbuilt regulator then regulates this input voltage to a stable 5 volt and 3.3 volt output, which then we use to power other components in our bot. The ultrasonic sensor. The ultrasonic sensor is used for detecting nearby objects. It works by emitting a sound wave through its transmitter and then listening for the echo with its receiver. This is similar to echolocation, which bats and dolphins use to detect objects in the dark. This sensor is accurate to within plus or minus 3 millimeters, and it can detect objects from as close as 2 centimeters up to a maximum of 4 meters. The ultrasonic sensor has 4 pins: a trigger pin, which starts the sound pulse, an echo pin, which receives the returning information, VCC, which is the input voltage, usually 5 volts, and ground, which serves as a reference point, also known as the point where voltage is 0. To find the distance between our sensor and an object, we can use the formula D equals to CT divided by 2, where C is the speed of sound, and T is the time it takes for the pulse to get to an object and back, which is why we divide by 2, because we only want one way. Next, we have the IR sensor, which we'll use for line detection. This sensor has an infrared emitter and a receiver as well as an indicator LED. This sensor is powered between 3 and 5 volts, but most people use it with 5 volts because it emits a stronger IR signal, which is more effective. Since the IR sensor detects changes in reflectivity, when it comes over a black surface or an opaque surface, the output pin goes high, indicating detection. This is shown by the LED as well, because when we are high, the LED lights up, and otherwise it stays low. Finally, let's talk about the motor driver. A motor driver helps us control how a motor moves. It's got 4 key parts: input pins, which you connect to the Arduino, and you can then tell the motor how fast to go and which way to spin. The output pins are connected to the actual motor. The voltage pin is where you connect your 5 volts to, and the ground is again a common reference in your circuit where the voltage is 0. And that is it for the parts information.